pool of data for specific attribute, like the social security number pool, is different from the data type. Actually, bigger concept of the data type. However, computer may not understand domain exactly. Sometimes you need huge memory data to keep all the social security number. Okay? Instead, why don't we limit the data as data type, like the 9-digit number, 9-byte character. That is the data type. So we are going to use such a domain concept based on the data type. Okay?
Sir, what is the difference between domain and attribute?
Attribute is
because they have the column.
Attribute is the schema. It's a description, like the address is set. But domain is the pool. It has all the example of address, like including 100 University Avenue, 101 University Avenue, 102 University Avenue, 103. Do I need to keep going? 1000?
No.
So it's all addresses in the world by following that format. But attribute itself is the name, address, ADDRESS.
My question, sir, you did put domain in two terms. One of them is for column, and
yes,
one of them
because attribute has the value of column in commercialized software, informal way. Actually, they do not use the domain. So it's very hard to match like that. Okay? To make us easy to understand the concept, the difference between the concept, we make the table. However, it's not exactly same, there is no exactly same concept as domain in informal way, because we do not use domain in commercialized software. Okay? So that is the reason sometimes it's in the column, it's in the value. Actually, both of them. Value, but they follow the attribute type. Okay? Then this is the example of the relation of student. We have relation name. It has number of tuples, Benjamin, Catherine, Dean, and whatever. Also, we can see group of attribute, name, social security number, home phone, address. We can realize each tuple has the same format, name, same value, social security number, and home phone. However, sometimes there is no data for specific attribute. For example, Benjamin does not have an office number, which means Benjamin has name, social security number, home phone, address, age, and GPA. That is different from Dick Davidson. Dick Davidson has only name, social security number, address, home office, age, and GPA. We cannot combine because they are different to address that problem. However, both of them are students. We can use null. What does null mean? Null means nothing, not exist.
It's not existing.
Okay? It's not NULL. It's not zero. It's not empty itself. It's nothing. No existing. So it's not positive, it's not negative, it's nothing. So that is the reason in database concept, true or false. Okay? How many types of data for true or false? True or false? Two types. Actually, in database, three types. True, false, or null. So that's a little bit different. So null is not existing. So we can make the same format between Benjamin and Dick Davidson. Then we can use the null. That doesn't mean it's NULL, no existing data. Okay? So these are the notation that we are frequently using in formal definition of relational model. For example, the capital letter R indicate the relation, or the attribute A1, A2, A3, something like that. Tuple will be the small letter, so you can easily understand the difference. For example, student has name, social security number, address, GPA, and so on. So this is the student relation. This is the one way to represent relational database. Okay? And sometimes student has a name attribute. Department has the name attribute. same name attribute, name. How can we differentiate such a same name? We can use relation name with the dot. So which means student dot name is name in student. Department dot name means name in department. We can differentiate such a duplicated name. Then it's easy to learn the relational database model because it is based on what? Set theory that you already know most of the things. Okay? Otherwise, it's a little bit hard. It's a little bit superficial if you do not understand the set theory. But everybody already knows the set theory, so it's easy to understand. Then what is the difference? What is the main characteristic of using relational database model rather than other database model? Actually, we don't have knowledge about the other database model, but we are going to investigate what is the benefit, what is the main characteristic of using relational database model. That can be summarized as a constraint. Because model, what is a model? It's a rule, policy, or constraint. It's a common thing. So we are going to find what is the main rule, or what is the main policy, what is the main constraint used in relational database model. That can be summarized as three things: key, entity integrity, and referential integrity constraint. First, key constraint. Can you remember the department entity that you designed that we learned in ER modeling? Department, so employee, department, as name, as the number, and location. Can you remember that? So we are going to use the department for the relation, characteristic of the relation. So how many key attributes we found from department? Two. Okay, if you read carefully the requirement of this company database, we have two: unique name, unique number. So we can use both of them as the key. So we have department. Using the relational model notation, we have name, attribute, number, attribute, and location. Why don't we consider location as a single attribute? A little bit complicated for multiple. And why don't you add one more thing, address. That's like that. We have two keys in terms of ER modeling. Then I'd like to identify the data or tuples. For example, name HR, 11, location New York, address, and so on. And payroll, 12, and New York, and so on. So we have the data. I'd like to find a specific department. First, using name. Is it possible to identify a specific department using name? Yes.
Yes.
Because name is unique. What about the number?
Yes. Yes, of course.
So we can find the specific. For example, 12 is payroll. What about name plus number.
Even better.
Yes, definitely. HR11 is unique, and Peter 12 is unique. What about the name plus location?
No.
Yes.
Can you identify
Yes.
specific?
Yes.
Yes or no?
Yes.
Yes, definitely, because name is unique,
Unique.
right? And what about address?
Yes.
Yes, definitely. What about number? Yes.
Yes.
So as long as you can identify the data, this set of attributes is called super key. Okay, what is a super key? A set of attributes that can identify the data. That doesn't mean only the key attribute. We don't know what is the key attribute yet. Key attribute that you know is in the ER modeling. That is toward different modeling techniques. So we are discussing relational model. In the relational model, first we define super key. What is a super key? Any set of key, group of key, set of attributes that can identify specific data. How many do we have? How many super key? Two? Even 1, 2, 3, 4, 5, 6. You can make as many as possible. There are many super keys actually. It's not a key, it's a super key. Okay? Then somebody may complain, why do you consider all of this? We can use only name. We can use only number to identify the data. Which means as long as a set of attributes has name or number or both, we can identify the data. Which means name and number are what?
Primary key.
Or attribute, or important attribute, or minimal super key. It's called a minimal super key to identify the data. So how many minimal super key over here?
Two.
Name and number. How many super key? We have so many super key. We can make as many combinations as possible. The reason is that first, in this case, it's easy to identify the minimal super key or even key. However, in real life system, you got a bunch of data printed from your customer. Your customer asks just to build a database. They do not know what is a key, what is a super key, what is a primary key. No, definitely not. You need to find that things. Then at that time, you can first think about how can I identify each data, each tuple. Can I use this one, this? Can I use this one, this? Can I use this, this? Then collect as many as possible, then try to find minimal super key. Important minimal attribute. Okay? That is called the minimal, the super key, or this is called the candidate key. This is candidate for key. Minimal super key is called candidate key. Yes, minimum. It's a minimized. Okay, we don't need the location, we don't need the address. So minimum that we have only name and number. It's a minimal super key. What is called candidate keys? How many candidate keys do we have in this example? Two. Okay, name and number. That doesn't mean name plus number, just one. It's not composite. Sometimes we have a composite key. For example, suppose the name and numbers are unique, but not each of them. At that time, we have only one. Okay, don't be confused with composite key. Okay, in this case, it's a single attribute key. Okay, this is called the candidate key. So Then in relational model, we need only one key to represent each relation. Like the how many chair does the CSE department have? One chair. And how many president in university? One president. How many president in one country? One. It's just one to represent each. So just like that, to represent this department relation, we need just one attribute as a key. That is called primary key. Okay? So here, among the candidate key, among the candidates, we need to select one key as a primary key. As name implies, it's a primary key. How many primary keys can each relation have?
One.
Just one. Only one. That is the first constraint in relational model. In ER model, sometimes we have multiple keys, right? However, in terms of relational model allow only one primary key. How to find the primary key? First, identify the super key, then the candidate key, then select one of them. But most of the cases, it's easy to find the candidate key or primary key directly, but not always. So that's the reason we need to consider this. For example, employee. Can you remember? Why don't you recall the employee? What can be the candidate key? How many super key actually can you find from employee? Many. Okay? You can make any combination as possible. With what? What can be the minimal super key? SSN or if you have employee ID, both of them are possible for candidate key. So let's say we have two candidates, social security number and employee ID. Then among them, we need to select one primary key. Then I have a question. Peter? Yes. Which one do you want? We have social security number, employee ID, not for employee relation in company database. Professor Lee says we need one primary key. So we have two candidates. Which one do we want? Select. SSN? Did I say? No, never ever. SSN? Why? Just Professor Lee says. Anyone else?
I think it's unique, and so it's
Both of them are unique because both.
If the employee, for example, quit the job or go to the other place, maybe someone will replace his place.
No.
Maybe this.
That's not the normal case. Yes.
Sir, all the students doesn't have the SSN. So.
Oh yeah, that can be, but that's not our assumption. So we are talking about the company database. So that means our assumption is all employee has the social security number to be paid. Yes.
Other options?
Yes.
I don't.
That's the general answer, but I need one. Yes.
Can I answer?
Yes.
The student ID.
And we are talking about the employee. Employee ID or social security
Employee
number?
ID.
Employee ID one.
Employee ID. Well, when you want to print salaries, you cannot print SSN on the as a unique attribute for every employee, because SSN should be security. So
For security reason, there can be one reason. If I were you, I'm going to select the employee ID because this is company database, right? Used in one company. So employee ID is most frequently accessed. Think about the application program that you are going to use. Do you want to remember the social security number for all the employee when you search the employee? Probably you will type employee ID. Probably you will be asked the student ID whenever you visit the international office or the registrar office, right? It depends on what? Requirement or your analysis of the requirement. If you have a bunch of the program or transaction that access social security number, you need to select the social security number as the primary key. However, if you realize all the transaction are accessed, all the transaction are using the employee ID to access the employee relation, at that time you can select employee ID rather than social security number. However, if your system is for payroll office, okay, or tax, at that time you'd better use social security number rather than employee ID. It depends on. So you can select either of them, but you should know why we need to select this. One more thing you can consider is, as he mentioned, it's kind of related the future. Potentially whether this can be duplicated, non-unique. For example, department. Who knows? Later somebody make the same name department. One name student database. I'd like to make the database for my student, only this class. There's no duplicated name. So I can use the name as the primary key. I select, but there's a registration who has the same name as him. Then it will be messed up. So you can think about the future. Another thing that you can consider is performance. In this case, name and number. Which one will be better in terms of performance?
Number.
Definitely number. Computer definitely likes to process number very, very fast. Anyway, no matter what types of data you have, it will be converted into number 0 or 1, such as ASCII code or the array, whatever, it will be number. So you'd better have the number as the primary key. But we will consider such a future purpose or performance in the class. It will be discussed in advanced database course. So you can just select based on your analysis of your program. Okay? Yes.
Sir, even the name, we can put like varchar, and the varchar can also like text.
I don't know anything about varchar.
Okay. We can use it as text, and this text will be converted into numbers. But this text has overhead inside the memory, not like, for example, numbers.
Yes, that's what I'm saying. So that's the overhead that we need to process more than number. Okay, that is the reason we prefer, not always, but we prefer the number as primary key. Okay. Yes. No. So that is, for example, in this case, so key constraint. We have the sample relation card. So say registration number, serial number, make, model key. How many keys can you find? How many super keys can you find? Many. Okay? Like we can use a state, registration number, serial number, make. We can use the registration number, make, model, and year. There are so many. Among them, you can select minimal super key that is called the candidate key. How many candidate keys? In this case, 2. One is state plus registration number. Sometimes we have the same plain number. Okay?
Yes.
The Michael Jackson in Korea, Michael Jackson in New York. Okay? So to identify state name plus registration number. Another key might be serial number. Among them, we need to select one of them as the primary key. How can we select? It depends on. Okay? So then that primary key should be underlined, just like the underlined key attribute in ER modeling. Don't be confused. ER modeling is a different modeling. This one is another modeling, database modeling, relational database modeling. Then we select the key to serial number as the key. Then what about the key one? Is there any specific name for key one? We called key 2 as the primary key. Then the other key, candidate key, will be called primary, then secondary key. It's called the secondary key. Secondary key is alternative way. Still, it's a unique. So it's good to access, to find the data. So we can use later. It's an alternative way. We will discuss about the secondary key in chapter 14 when we discuss about the indexing. Okay? So this is the example. In this case, license number, state plus registration name is selected. Why? Can you guess why the author selected this as the primary key rather than the engine underbar serial underbar number? Both of them are unique.
One of them, if you see that number, if you put it in the license plate, you cannot understand that this car belongs to that state or the other state. It doesn't give me more information, more description. It's not more descriptive.
Engine can damage anytime and you might need to exchange it.
And she said somebody changed the engine. Yes, that's true. I never heard about there is an engine serial number until I look at this slide, which means there might be a lot of transaction program that access license number, right? Why don't you think of when you visit the DMV? Probably, I'd like to register my car. If you give the engine serial number to them, definitely not. Probably all the system use license number rather than, it's not very popular. No system use engine serial number, even though they are unique. So that is the reason probably the author selected this one as the primary key. It's the same thing. When you decide the primary key in the project, you need to think about, there's no general. So sometimes a student come by my office, then what is the possible primary? No, I don't know. It depends on your requirement. So you need to find based on your requirement. Okay? Then we can have the employee relation, department relation, and project relation, dependent relation. Those relation, those set, many set, actually describe what? Company database. To describe, our goal is to build a company database. So that is the reason we are doing modeling. Then through the modeling we identify, we have the relations, like the student and employee relation, departmental relation, project relation. These are the relations, and by grouping a set of relations can describe the database. So this is called the schema of your database. What is a schema? Schema is a description. Okay? A set of relations can describe your database. So your goal is to find such a relation, not schema. Okay, that is called the relational schema. Okay. Then another. So first characteristic is each relation has what? Primary key. Okay, that key is a unique. So it's a unique, but sometimes we have a multiple unique attribute. We can select the most appropriate, the one as a primary key. Then the next one is I have the very simple database relation, the ABC relation. Okay, it has just one attribute. Zero, one, two, null data. Okay. Do you think this is unique color, unique attribute number? Unique or not?
Yeah.
No.
No. Yes. Yes. And no.
No. The primary key cannot be now. Then you have.
I like the in the middle.
Yeah.
I can be either of them.
Yeah. No.
What about this? We have another one. Is it still it's a unique or not?
No.
So what does that mean unique? Or what does it mean the duplicate? You need to compare. Okay? So whether this is the same or not. Whether this is the same or not. Whether this is same or not. However, can you compare something that doesn't exist?
No.
Is it possible?
No.
No. So this is even we cannot consider the comparison. We cannot compare the data. We don't know. We cannot. It is impossible to decide whether this is the same or this is different. So we can do only these 3 tuples. So it's unique. Okay? Null cannot be compared. Null doesn't exist. Then what about the primary key? Primary key, when we decide the primary key, it's based on the candidate key, it's based on the super key. Super key, as long as we can identify. But identifying is not formal definition. Actually unique. Okay? Still unique. We cannot. We don't have to worry about the null. Doesn't exist. So it's unique. We can select as the number. However, think about we have something more data. Name and ID whatsoever. So lead and pattern names and so on. I'd like to access this data through primary key. Can you find this data? No. Because it's null. You cannot find it. It doesn't exist value. Even though there is a tuple. So it's not perfect as a primary key using uniqueness. Instead, it should be not null. So primary key should be unique as well as not null. Probably some of you guys heard about the primary key is unique plus not null. That is the reason. Primary key should be unique and should be not null. Then I can identify the data, all the data. Okay? This is one of the frequent questions in database certificate exam or similar. Okay? So this is that is called entity integrity constraint. So first constraint, first rule is primary key. It's a unit. Second rule is primary key is not null data. Okay. The next one, third one is referential integrity. Let me use employee and department. Okay. So we have two relations, employees. So employee ID and the employee name and email and address. Also we have department and number, name and phone number. So we have two relations. First constraint, each unit. The one has the key as primary key. That should be unique, so we decide to use N number. Okay? And D number as the primary key of department. Not a problem. Then, after you build the house, what you guys need to do is live in there. Right? We need insert the data. We need to create data. That is called population. Populate the database. We need to insert the tuples. For example, employer ID 111, e-name Lee, email, whatever, address. Does it make sense? Do you think it's okay?
Can you repeat, please?
We just insert the one data, 111 Lee, 1. So this is a unique and this is not null. Any problem?
No. No?
Do you have the department number 1?
No.
Yeah.
Where is it?
We don't know.
We don't know. So it doesn't make sense. There's no department. Then how can we hire the person? Before that, we need to have the department. HR. Point number 1. And we can create it. Then next, employee ID 222, James. And 1. Then it's okay. It's a key, unique, non-null, and this images. The department. Then 333, the capture. What about 2? We cannot create it. Okay? We cannot create the data. This, which means DNO attribute rely on the value in D number in department. So at that time, this one is called referencing attribute, referencing relation. Referencing what? Referencing. Referencing. This is a reference. Okay, referencing and referenced. Yes.
We can use it as a secondary key, the department number.
Secondary key is a good question, but we will learn later. Just think about the primary key. Okay? Then even I do not explain that one. Okay? That make other students confused. Okay, let's see this one. Whenever we insert, populate the data in employee, we need to take a look at D number in department. At that time, this is called the referencing, and this is a referenced. Okay? This is called referential integrity. This is a third rule, third constraint, third condition in relation. Sometimes one attribute should rely on the other attribute. The other attribute, reference attribute, should be primary key of this one. Otherwise, for example, this is not the primary key. 1 HR, 1 payroll. Because this is not the primary key, we can have a duplicate data. At that time, 1. Which one? HR, payroll? How can you decide it? So this one should be primary key of this relation. Then secondary key can be doable, but we do not consider secondary key yet. But secondary key can be referenced one. But forget about it. So just referenced column should be primary key of this. This is called referential integrity. Or this is called foreign key constraint. I think you already know about the foreign key. Right now, you know exactly what's the definition of foreign key. Foreign key is one of the important constraints in relational database model. Actually, that differentiates from other database models. Other database model actually has the primary key, actually has the uniqueness, actually has the non-null, but that does not have foreign key relationship. Using that foreign key constraint, we can represent very complicated relationship of your database in the database system. Okay, that is a benefit. However, it's not easy to manage. For example, when you create the relation, can I create a relation EMP without department? No. When you create the employee with a foreign key, you need to check whether this is reference to one exists. That is a reason. That is the first common mistake when you create the table. I cannot create. I know how to create the foreign key, so you specify everything, but you cannot create. Because your reference table should be created first. Then you can create this table. This is called the foreign key constraint, referential integrity constraint. We learned the three constraints, major rule in relational model: unique, non-null, and foreign key. Okay? So let's find the more example of the foreign key from here. Actually, this one is the company database. We are going to use, this is the employee department, location, project, work zone, and dependent. That means this is a schema of company database. This is called the schema. Then, what types of schema? Relational schema. This schema is based on relational model. So this is called relational schema. Also, we are going to use diagram, block diagram, right? It's a little bit different from the notation that I use. Here I use the parenthesis and using comma. This one use the block, and for each block is for attribute. Also we can use underline for primary key. This is called relational schema diagram. As if we build the ER diagram in relational model, this is our goal throughout the modeling. So if you can draw this diagram, it's good. But except what? We do not have foreign key yet. Okay, let's find the foreign key together. So
B. Letter. Can you put letter B?
Hold on.
To turn off the screen,
Okay,
it's letter B.
Okay. Here, first we already find the arrow to the number. So we are going to use arrow to represent foreign key. Referencing and reference. Reference should have arrow, head of the arrow. Many students actually forgot in your exam. They know, I know. Students know which one is the reference and which one is the referencing, but they forgot about this. You should have the direction. Then we can realize this is the reference one. Reference one should be underlined. Why? It should be primary key. Anything else? You want? Can you find one foreign key?
Department number.
Oh, he is answering.
Okay, the department number and the
Department number.
and the employee and the next one, the department number.
At the bottom.
This one.
No, department number is
There's
location.
this one.
Yeah.
You can say the number in the DPT location. Okay.
Reference.
And it's referring one.
Referencing.
Reference.
Which one?
To the
From here to where?
to the department.
Department. This.
No, to the
No.
department number.
D number in
Yeah.
department.
Yeah.
Okay. So you can say D number in department location left first. D number in department. Anything else? Monica? Yes. Can you find
The phone number.
phone number? Where's the phone number?
Project.
Project phone number.
Project number.
P number. Okay. Project number.
And works on.
Works on
The project number is
this. Do you think which one is the more important in terms of project? Project or works on? Project. Okay? So project number in project should be primary. Okay? Then P number in work zone. Sometimes you have the data if the employee is assigned, sometimes not. So which means this P number should depend on P number in project. Okay? If you do not have the data over here, definitely you do not have the, should not have the data in work zone. Then you can easily decide which one is which. And command print. Yes.
D number in project to D number in department locations.
D
In
D number in project.
department, D number in department
Yes,
locations.
it's good. Okay, right? And anything else? And Yungfu? Yes.
The ESSN independent.
Yes, good. This ESN definitely depends on social security number in employee. Even in ER modeling, we already consider as a weak entity, right? And anything else? Yes.
Super assistant. Yes.
Super assistant, good. It's not only for the different relation. Sometimes in one relation, this super assistant should exist in SSN in the same relation. Okay, good. Anything else? Yes.
Works on ESSN with SSN on employee.
Yes. It's not going to here. It's not going to where. Going to SSN. Anything else?
Yes.
I think pretty much.
Yes, there's a also
Which one? Yes.
MGR SSN
Oh yes.
with SSN.
Manager social security number this. Then what about this? Key location. Key location. Different
No,
locations.
it's not related.
They are totally separated, independent. So don't be confused with the name. You need to think of, because you already know the description of this database. So that is the reason it's easy to identify the foreign key. But in real life system, sometimes it's not easy. Also, don't be confused with the name. That is the reason naming rule is also important. Somebody who do not know your database may be confused. Oh, this is the name, this is the name. So they may be considered as a foreign key. So don't be confused with such a name. Okay. Then after you find the whole the foreign key like this is the final output. Also one more thing is, even though this is the one primary key, each attribute depends on the primary key of this one, okay? So that is the reason I like the representation notation from attribute inside the box to inside the box, not outside the boundary of the box. Then, this is the relational schema for employee. Department location, department. Then, for each relation based on the constraint, you need to consider the constraint. Unique, non-null for primary key, and foreign key constraint. Then you can create, insert the data, populated data. So this is called database state. Database state means after you design the schema, then you can, based on the constraint, by considering the constraint, you can create the table. Definitely ESSN and P number will be unique and non-null. Also, their ESSN should be exist in the referenced attribute, social security number. So it's already considered all the constraints. Then this is the database that we are going to build at the end of the semester. Okay? In your project, right now it's just the initial step. Eventually, you will build such a database state. Okay? After you build this one, that's not the all. That's the page 3. In page 4, we need implement the program to use this database. That's the overall things that we are going to do. So, after we create the database, like the database state, we need to take care of the data. Why don't you think about the object-oriented modeling? In the object-oriented modeling, why bring the right one? I need to check the time.
45.
So,
4 moments.
4 minutes? 3 minutes? Let's see now. So this is the operation. So this is the quiz. In this quiz, we have the database schema for after class. We have a class for the car sales system, database, car relation, option relation, sale relation, salesperson relation. Each of them has the primary key, which is underlined. Then, first question, find the foreign key. Even though I do not provide detailed information, but using common sense, from the naming rule, you can find easily as many foreign keys as possible. Then, number 2, draw the ER diagram. Then number 3 is based on your, not ER diagram, relational schema diagram, including primary key as well as a foreign key arrow. Using that relational schema diagram, why don't you create at least 2 or 3 sample data? Okay? At that time, you need to consider primary key, uniqueness, non-null, also foreign key.